What I love about talking to you application engineers is you're very good at taking kind of complex ideas like we're talking about today and sort of distilling it in ways that even like I can understand, which isn't always easy. So can you give us kind of the Cliff Notes version of how viscous and variable speed technology, I mean, it helps with a lot more than just temperatures. You're talking about noise, you mentioned emissions, performance, efficiency, kind of dive into that a little bit.
Well, sometimes I think we have to simplify it for ourselves so we can actually understand it too. But yeah, those are the big drivers. So you have your noise emissions is getting huge. It's like I said earlier, we have construction sites where a lot of times they're in residential development areas and whatnot, or even like downtown in large cities, and you need to be able to have that. You need to be able to have it under a certain limit, and a lot of cities have strict regulations of what that needs to be. So the viscous clutch helps reduce the fan speed, and then in turn helps reduce the noise. That's the same thing with emissions. So you have running less fan speed, running less fan, so you're going to have less power draw, and when you have less power draw, you have better fuel consumption, and then you also have less emissions. And then on the another side of that is a lot of our applications are diesel engines. So in fact, probably the overwhelming majority that I work with are diesel engines. So diesels have to run hot. I mean, they have to run within a certain temp and a certain load. So overcooling tends to cause a whole nother bunch of issues for diesels. And a lot of times, especially in our colder climates, when you're running a viscous clutch or you're running a cooling, you're just running a direct drive fan setup, you're going to overcool. So it really helps to have that viscous clutch to be able to slow that fan down so you're not overcooling, so you're just dialing in and cooling exactly where you need to be.